you all are making a class, just like those elements are making matter. Yes or no? So you understood the difference? Let's say this is element 1 and this is element 2. Both of them are combined. Shake your hands. So now they are making some bonds. Can be covalent, ionic, metallic, anything. Okay. Now this is a compound because this element is different, this element is different, right? Still they are pure. They are still pure but different, okay, different from element, right? So if let's say in this entire room only these two, like these two have form of compound A, let's say only compound A is present and none of you are present, then again it is a pure substance. Yes or no? Are you getting my example or not? Or is it too complicated? Understood? But let's say these are two what? These two are one compound and these two are another compounds, right? Now, when I'm mixing these two, I will get a mixture, right? If this is in less quantity and this is in more quantity, this will be our solute and this will be our solvent. That is how you make a solution, okay, a mixture. So, any doubt in element and compound? Your example of elements are hydrogen, oxygen, iron, Au, anything. All are elements. And compounds are, yeah, when two elements combine to form compound. For example, hydrogen and oxygen are combined to form H2O. And why not HO? Why H2O? Let's say this is oxygen. This is oxygen. Shake hands with them. So this is what? OH. But he has still one more hand to make another bond with another hydrogen. Yes or no? So it all depends on its valency, on its covalency. Yes or no? So it will be different for different elements. For example, chlorine. How many covalency it has? Are you sure? Okay, what is the difference between valency and valence electron? Can you tell me? What is the valency? 1. Can you recall any element in which chlorine is making 5 bonds? PCl 5. That phosphorus is making 5 bonds, not chlorine. Chlorine, there is like very few example. Only fluorine can like do that. Interhalogen compounds are there. BRFI you must have seen. Let's say, okay, chlorine does not make 5 bonds usually. So valency is number of like bonds it can make, and valence electrons are the number of electrons present in the outermost shell to make the. Hey, you can break the bond. Okay. So you understood the difference between valence electron and valency, right? Who doesn't understand? Tell me, please. I will explain again. Covalency is something that's already make the bond. In that specific compound, how many bonds it is making? For example, PCl5, phosphorus is making 5 bonds. In PCl3, he is making 3 bonds, right? So its valency is 5, but covalency is in that specific compound, how many bonds it is making? In PCl5, it is 5. In PCl3, it will be 3. Got it? So I guess this is something you are studying from class 9th. I don't need to spend more time over here. And homogeneous mixture and heterogeneous mixture, who will tell the difference? I told you that day also homogeneous is what? When your solute and solvent are mixed properly and in the entire solution. Let's say I have a glass of water. The amount of solute in the above part and in the below part, if it is same, then it is a homogeneous mixture, homogeneous solution. Okay. Give your water bottle. For the students who are coming for the first time, let's say I'm making a lemonade. Okay, I'm adding sugar in the water and lemon juice. So sugar, if I stirred completely, so it will be dissolved in this water, right? So if I taste the water above, which is present above the surface, and if I taste the water which is present below, if both are tasting the same, it means what? The concentration in both the part is, if it is same, it is not. It means what? It is a homogeneous solution. And heterogeneous is what? Your sand and water. When you can clearly see the separation, right? You can clearly separate very easily. Even oil and water is also mixed heterogeneous. Right now that E20 thing is going on. You know what is the problem with that E20 fuel? when you mix ethanol with petrol, okay, it's good, it's calorific, like it will give you a nice amount of energy just like petrol, it will be cheaper for us. But the problem is the ethanol can attract water molecules because ethanol can mix hydrogen bonding. Okay, so once it is around, let's say you are filling the petrol, you just forgot to turn off the cap quickly. What will happen? The moisture will be in the like around the air. It will quickly absorb that moisture and it will separate out. Okay, so ethanol will, because it is heavier than petrol, it will go and bend, go in the down the surface, and it can start rusting because there is moisture. It can rust the engine, and it can your vehicle can be destroyed because of that. So that is why people are mad, because some vehicles which are like made in 24, they are E20 compatible, but which are not made accordingly that. For example, if your dad has bought some car in 2016 or 15, so those cars are not E20 compatible. Okay, so that is why all the anger is. I hope you all get it. Next is, what is mole? I told you, anything which has Na particles. Na means Avogadro number 6.022 into 10 to the power 23 particles. It will be equal to 1 mole. Yes or no? So I have a very interesting question for you. Okay, just to tell you how much of the bigger number is 1 mole. I have a question for you. Write it. If you were given $100 billion, if you were given $100 bill, and you could spend $1 million every single seconds, and you can spend $1 million every second, how long would it take? How long would it take you? How long would it take you to spend $1 mole? How long would it take you to spend $1 mole? How many dollars in 1 mole? Very good. So try to solve it. How many zeros are in 1 billion? 6? 6 zeros are in 1 million, no? 9. Okay, I am asking 1 billion, no? So you can multiply by 100. M. 100 billion, 1 million. Two numbers are there in the question. Okay. What is this number? What is the point? You have $100 billion. Like, this is the rate. If you are given $100 billion bill and you can spend $1 million every second, you are spending $1 million in 1 second. Actually, this is actually of no use for you. 100 billion is of no use in this question. 100 billion is of no use. You can use simple unitary method. If you have 1 mole dollars, how much time it will take to spend that? Okay. The question is saying you are spending $1 million in 1 second, right? The time you will get in will be in seconds, right? And if I ask you to find the time in years, you can. I think you can convert. How much? 10 to the power 16 minutes. 10 to the power 16 minutes. Can you convert that into years? How many years it will take? One million is 10 to the power 6, right? 1 million is 10 to the power 6. This is the time you are getting, no, in seconds. For the students who don't know how to use unity method, just I'm telling you. For example, the question mentions that you are spending $1 million in 1 second per second, and the question is asking if you are given one mole dollars, how much time it will take. So in one mole dollar, I have 6.022 into $23, right? 6.022 into 10 to the power 23. So whoever is a new, whoever doesn't understand, they can ask me anytime. Okay, I will repeat it. So for spending this much, how much time it will take? So it is t. So what I did, just cross multiply these two terms. T into 10 to the power 6 is equals to 1 into this Avogadro number. And by solving that, I will get the t as this much. Now I want the answer in years. How will you convert second into years? Why is it happening like that? 1 year has how many seconds? 60 into 60 into 24 into 365, right? 60 into 60 into 24 hours into 365 days. You can use calculator. One year is equals to 365 days. One day is 24 hours. 1 hour is 60 minutes. 60 minutes is 60 seconds. So this is equal to this much, right? It means what? 1 second will be what? I will send everything down to 1 year. So 1 over 365 into 24 into 60 into 60, right? So I got the value for 1 second. I just have to replace it with this 1 second, right? So what will I do? 6.022 into 10 to the power 23 multiplied by, because 1 second is what? This many years, right? This many years. Sorry if like it is not visible, but I guess you can write in your notebooks. 1 by 365 into 24 into 60 into 60. Anyone got the answer? 1.9 to 16 years. You know how many years is that? It is 19 trillion years. If you are spending $1 million in 1 second, even though to spend 1 mole, it will be $19 trillion. And you know what is the age of our universe? 13.5 billions. And what is the age of Earth? 4.5, right? So our even the time is not like your universe is also not that old to spend that much amount of money. So that's, you can imagine how much huge number that is. Okay. Everyone is done? Should we move to the next topic? Okay. Now, the thing is 1 AMU, 1 atomic mass unit. So what is the 1 atomic mass unit? 1/12 of carbon 12. Right? 1/12 of carbon 12. And one thing you have to remember, in 1 mole of carbon, we have 12 grams of carbon. Right? In 1 mole of carbon, so we have 12 grams. That is what I was mentioning in the before the class. Let's say I have 12 grams of carbon, the black carbon in my hands right now. Exactly 12 grams. So I can say, yeah, it has 1 mole of carbon. And it has 6.022 into 10 to the power 23 number of carbon atoms in my hands. Yes or no? You get it? So why do we use grams, AMU? Because when we are measuring the actual weight of these small atoms that are very less, it cannot be measured in our normal weighing scale. Okay. So our normal scale will be what? Grams, kgs. But can you measure your one atom on that gram scale? No, it is impossible to measure that. That's why we needed a different scale. So all scientists came up with an idea. We will now from onwards, we will measure the mass in AMU, atomic mass unit. Right? That will be the unit for mass of elements, right? Or compounds. And this was the conversion, the mole map. Let's say you if you have to find the number of mole from number of particles. So which equation you should use? I told you two equation to remember. Okay, number of mole is equals to given mass by molecular weight. Please write this equation. And the second equation I told you, number of particles is equals to n into Avogadro number. Let's say I say 1 mole of banana. It means what? 1 Na. If I say 2 mole, it means 2 Na. Similarly, if I say 10 mole, it means 10 into Avogadro number. Simple. Let's say in some question, you have been given moles and someone asks you the number of particles present. Let's say I ask you how many particles will be there in 1 mole. What will you do? This has been asked and this is given 1 mole, 1 into Na. Yes or no? Okay. This formula you already know, right? You wrote in the last class. Number of particles is equals to n into Na and number of mole is equals to mass by molar mass. Okay, one very interesting thing that I was thinking yesterday. I want you to answer it. The formula for number of mole is, let's say, mass by molar mass. What is the unit we'll take here, W? Grams. Very good. What is the unit we take for the molecular weight of any compound? AMU. Let's say I have 36 grams of water. So for water you said 18 AMU, no? H2O. This is something you take in AMU. How can you divide two terms? Because when I say number of mole, it should be 1 mole of something, right? They should get cancelled. Your answer, the unit you should be left with should be 1 mole. Are you understanding the question what I am trying to ask? Yes. You can divide only those terms which have same units. Let's say you are dividing 2x by 2x. What will you get? Let's say you are dividing 2x by 3x. What will you get? 2 by 3? X will be cancelled. Does 2 by 3 have any unit? It is unitless. But after solving this, I should get answer in mole. Yes or no? How will I get that? The mole is defined as? That is what I'm asking. That is what I'm asking. Just tell me what is 1 AMU. 1 upon Na. 1 upon 1 AMU is nothing but 1 upon Na. And Na of anything is mole. When I will write like this, this will be gram. It will be what? Gram upon Na. This is cancelled. It will be like 1 Na. And 1 Na is nothing but mole. Fine. So try to think the formula like this. And these are the formula. Okay, volume I forgot. For at I guess I told you the difference between STP and NTP that day. Remember? The current definition is of STP is what? 0 degree Celsius. Temperature, everything is same, but the volume is 22.7. Right? How did we get it? From the ideal gas equation. PV is equals to nRT. From that, you can find it. Okay. Pressure is we know because we are keeping everything standard. Okay. Pressure we know. We know the gas constant, that is 0.0821. Okay. One more question. Like I to till date, like I always get confused between the like when we use R 0.08 and when do we use R 8.31. You guys are getting my questions? When do we use the R as 25 by 3 or 0.0821 on when, and when do we use R as 8.3? Can you tell me? Whenever you are dealing with ATM and liters, like for example here your pressure will be ATMs, volume will be liters. In these questions you will use R as 0.0821. Fine. But when you are dealing with joules, okay, whenever you are dealing with joules energy, you will use 8.321. Okay, that 8.3 basically. Getting my point or not? Write it down in your notebook somewhere and like marking it at note at the top of your notebook. Whenever you are studying these notes, you'll remember it. When do we use R as 0.0821 and whenever you use 8.3? For example, you must have seen in the physics average kinetic energy or VRMS 3 by 2 RT, no? Where there are mostly energies are in joules, right? Then you have to use R as 8.3. Fine. And I guess you should not be having any problem with these formulas already we discussed. Something will be given, something will be asked. You're studying from class 9 this thing. You're getting everything? New guys, raise your hands. Getting everything, no? Speed is fine. If you are feeling any doubt, you can ask me right now or after the class. Okay, it's fine. This question. Oh, don't see the answer. Tell me the answer. New guys, solve it. How many moles are present in 36 grams of water? I guess I extended this question no, to ions, to charge. Yes, I did. I think you all can do it very easily. Number of mole is equals to given mass by molar mass. Given mass in this question 36 grams and you know the molar mass is what? 18. Cancel it, you get 2. And they are asking number of molecules. So number is what? N into Na. So N is what? 2. 2 multiplied by Na is, you can do it. 2 into 6.022 into 10 power 23. Fine. Okay. Just quickly, I want the answer in like 1 minute. Quickly do it. Some PYQs are there. You want? You can read this, right? I want the answer from you two guys. Misbah. Who is Misbah? Misbah, I want answer from you. That's what I'm asking. No? If you are not able to like read properly, you can ask. Fine. (108). Atomic mass of silver is 108. Remember it. So this is the beginning of everything. So we are going very slow. but slowly we will catch speed. Okay. So whoever is like feeling like we are, I'm not boring you guys, no, because we am like teaching the same topic again. I just want to make sure. Which answer? D. B. B. D. Everyone got the answer D. You did not got the answer. Hmm. So you said you're not getting what answer good. D. Oh, very good. Very good. Everyone, please say it. Which of the following has maximum number of atoms? Which formula should I use? Everyone, tell me. Number is equals to n into how many number of moles? Now again, number of mole is mass by molar mass. Your mass is same, Na is same. Now only thing which is different is your molecular weight, right? So if my molecular weight is more, number of particles will be less, and we want maximum. So molecular weight should be less. Yes or no? So in this case, it is 1 by lithium is what? 1, 2, 3. Hydrogen, helium, yes. 3, no? And for this case, it is 1 by 32. It is 1 by 24. 1 by 108. So the smallest number is this one. If this is smallest, this will be maximum. Oh, I just wrote the atomic number. Sorry. 1 by 7. Fine, fine, fine. So don't do such a silly mistake in the exam. But obviously we got the right answer. Anyways. The number of water molecule is maximum in? For the volume, it is much easier. Because number of moles and volumes are directly proportional, okay? Number of mole is equals to volume in, upon 22.4. Okay? So it is directly proportional to number of moles. So volume is more, then number of mole will be more. So in this case, I guess, okay, you have to convert everything, no? Because someone is in grams, someone is molecule, someone is again in grams. So 18 mole will be having 18 Na, or yeah, 18 Na particles over there. So you can convert it, or should I solve it each step? Should I move forward? Very good. Okay, this is a good question. This year in NEET it was been asked. Try it. Bolo. Okay, you don't know the formula of urea? Come on, Ucho. Can you tell me the formula of urea? It is CONS2 whole twice. Remember it like this. Molecular weight is 60. I can't see it. There's a problem. So you can come on the first bench. No, come. You're sitting for so long. You should have sit here. Come. Whoever has any problem in seeing, please tell me. What happened? Given mass by molar mass, number of moles into molar number divided by 4. Right. Into 4 or divided by 4? No, no, multiplied, no. Number will increase. What happened?
First, I found the numbers of the gram of hydrogen and then the number of moles. 2 by 100, 0.02. Then answer.
You did. First of all, you have to find the number of mole of urea. What is this? What you did?
60 grams urea contains 4 grams
Four.
of hydrogen.
Okay.
5.4.
Okay, like that also you can go.
36 by 100 grams of hydrogen.
In
Oh, I did 18. It's H2.
urea. People are using different method for this. Okay, I'm okay with anyone. Like just as long as you are getting right answer.
Previous question.
Different. Mole is different from molecules. One mole contain, if I say one mole, it means any number of that thing. One molecule means only one molecule. If I say one molecule of water, it means only one molecule of water. Okay. It's different. One mole molecule has one mole molecule has 6 into 10^23 molecules of water. And one molecule of water is only one molecule of water, only one H2. Get it? See. Hey, what happened? Who has got the answer? Raise your hands. Misbah, what happened?
You can find which percentage.
No. The question is asking about number of hydrogen atom present in 5.5. First of all, you have to find the 4 gram of urea. Find the number of mole from the number of mole will be what? Given mass by molar mass. Okay. In 1 mole, and they are asking us explicitly about hydrogen. So in 1 urea, you have 4 hydrogens. Okay. So in 1 mole, it will be 4 mole of hydrogens. No. So find the given mass is 5.4. Molecular is 60 into 4. Just do like that. Simple. Yes. Now everyone please. Who is saying B? You got the answer? A lot of students are not present, I guess, in this class. I don't know. Yeah. So answer is B, you are saying. Okay. Please come and solve with me. C, okay, fine. Let's see. So the question is asking about number of hydrogen atoms. Okay. Either number of hydrogen atoms. But number of anything is what? Mole into Na? Number of mole into Na. Let's say I have 1 mole of urea. How many hydrogen atoms will I have? So let's say if I have n mole of urea, how many atoms will I have? 4 into Na? 4 into n? When I'm solving in the board, please solve with me. Okay. Then don't discuss. Stop discussion. So by what number I should multiply? If I have 5 urea, 5 mole urea, I will have what? 20 mole hydrogen because it is 4 times of that. Right? So into 4. Simple. Now, given mass is 5.4 grams and molecular weight is 60 multiplied by Avogadro number multiplied by 4. When you will solve it, I don't know. I think everyone is getting C, so it will be there. Everyone did the same thing, right? Okay, very good. Second part. This is also a very good question. If Avogadro number Na is changed, what will happen? Mostly questions have asked you in AIPMT and NEET. Don't have to solve anything. Just see. C. Who is saying C? Okay, C. Use your brain for 1 minute and then tell me. D. Okay, who the like students with D, please raise your hands. Students with C and rest of them, all of the above. Still thinking? Think. I'll tell you. Let's make some suspense. You guys are getting the video recordings of the lectures? So since you all are getting video lectures, don't think like that I will like just see the lectures and it will be enough for me. Please be in the class, okay? In the class, you'll learn like differently. Done? So people with A, B, C, good number of people, very good. D, raise your hands now. So the D is the right answer. Okay. Why I'm telling you? Because it's a tricky question actually. It's a very nice question. If I change the Na, what will happen? Okay. The C option says the definition of mass in units of grams. Because grams, let's say I'm measuring 12 grams something. If I change the value of Na, what will happen? Nothing will happen, no. My measuring scale in gram or kilogram, it will be same only. The only thing that will change when we are coming into subatomic particles, protons, electrons, neutrons, right? So let's say the mass of 1 mole of carbon, okay. When we define 1 mole of carbon, we say Na particles. And if Na is changed, your mole definition will also change, no? The number of particles will be reduced. Initially it was 23, now 20. It is 1000 times less. Yes or no? Not. Krishna, why are you sleeping?
I'm not sleeping.
What I said, tell me. Stand up. What I told, repeat.
I found out that I found out that मतलब अब like ग्राम में फर्क नहीं पड़ेगा क्योंकि
ग्राम्स हम लोग बड़ी चीजों के लिए यूज करते हैं. वी यूज फॉर बिगर थिंग्स, ओके.
चीजों के लिए फर्क नहीं पड़ेगा.
Exactly. Fine. Because this grams, we don't need any Na values for measuring grams, okay. If I have, let's say, 12 grams of something and Na value is changed, it will again be measured 12 grams only. Yes or no? Because it is not mentioned in mu. Okay, mu will change. It's a good question. Okay. Quickly, I want to answer in like 1 minute. First question. What is normality? Normality is molarity into n factor. Okay. Molarity into n factor. What is n factor?
So it's like the amount of ion that increase.
It can be the number of ions it is forming, number of electrons it is exchanging. Okay. Whatever it is, it will be your n factor. For example, in S3PO4, if you will break it down, you can get 3x plus and what? PO4 minus 3. So basically there are exchange of 3 electrons. Yes or no? There are exchange of 3 electrons. It is gaining 3 electrons, it is losing 3 electrons, hydrogens. So that's why n factor become 3. And you know the molarity is equals to normality is equals to m into, tell me everyone, molarity into, so it will be
Can you derive that from normality is equal to mass by
mass by
equivalent?
equivalent mass.
That is the definition of normality.
You are talking about equivalent mass, I guess. Equivalent mass is equals to molecular weight by n factor. That is what you are mentioning, I guess.
So what's the definition of normality?
Normality is like when you are finding equivalence of something like molarity into n factor. Because what we assume that this is the let's say if I have 0.3 molar phosphoric acid, I should worry like I should think like I have only 0.3 molar. But when you will actually measure it will be 0.9. Then you will think why it is coming 0.9. Then you will have to consider it is going to dissociate. It will dissociate and it will increase, the concentration will increase because of that. You're getting it? So normality is different from molarity. Normality is actual concentration. Okay. Second part. Getting everything? Yeah. Sure? Pariniti, no? What? Pratiksha. You getting? What is your name? Yeah, yo. Suhana. You have specs?
I just forgot to carry forward.
Okay. Because I also had different spec. I broke it yesterday. But I had to go to buy new specs. Please bring your specs.
Yeah, I'm getting it.
Yeah, why AC is not working? Or is it working?
One is on, other is off.
Why is it taking so long? What is the question asking? Number of atoms. In a number of atom means what? What formula you have to use? N into Na? Mole into Na. It's giving 0.1 mole.
1 into 0 point and S2 and S23.
0.1 into, do it now. What are you thinking? But one thing will change, it is triatomic gas. You have to multiply it by 3. Whatever moles you are getting, it will multiply by 3 because there is not one atom.
So,
You have to multiply by 3. Got it? Sure. Very good. Prashant? Didn't get the answer? Which one? You got the answer? Right now, this one question, no? So, it is asking number of atoms in 0.1 mole triatomic gas. If I have 1 mole gas, how many atoms I will have? Na atoms. If I have 0.1, I will have 0.1 Na. But it is triatomic gas. And in triatomic means I have 3 atoms in one gas. So it is asking total number of atoms, just like that urea question. Remember the 4 hydrogens were there in one molecule. So in this molecule you have 3 atoms. So whatever answer you are getting, will multiply by 3. 0.1 into Na into 3. Simple. Prashant, help him. Okay, if you are not getting anything now. You can ask your friends and you can ask me also after the class. Yes, beta.
This before you thought that was okay.
POAC.
This is also okay.
Arey, why are you studying this thing right now? I'm teaching something else, no? For doubt, I have time. I told you, after the class, you can ask me doubt. Don't worry, I'm here only. I will end the class in 50 minutes and then you can ask the doubt. Please focus whatever is going on in the class right now. Don't try to study whatever like next topics. Okay. So solve with me. Number of atoms they are asking. Okay, number of atoms. What is the formula? Tell me. Everyone, please. N into Na. So in one molecule, we have 3 atoms because it's a triatomic gas, right? Like A3, okay, or N3, something like that. So whatever answer I'm getting, I have to multiply it by 3 because it is asking for specific atoms. In 1 mole, I have 3 atoms, 3 mole of atoms. So if whatever n number of mole will be there, I have to multiply it by 3. Got it? And then you have to just solve it. 0.1 into Na into 3. So 3 into N is around 1.8, something like. Which one are there? B for ball. Calculation is your part. I will just tell you how to do it. Fine? Okay. POAC I will teach in the next class. POAC I will teach in the next class, okay? because I guess some questions are still left. This was asked in NEST. It's a good question. Please, everyone, use pen and paper quickly. I want the answer. So this is physical chemistry. Physical chemistry demands for practice, okay? Like question practices. So that's why I'm like giving you so many questions. I will not teach the same thing in organic and inorganic. I have different methodologies, okay?
रेड कलर जैसा कलर यूज करो
हम्म।
मीटिंग के लिए ऑनलाइन में लोग बोल रहे हैं कि ये लोगों ने देख नहीं रहा है
अच्छा, okay. So gas at 273 Kelvin and 1 atm has a density this much. Its molar mass is closer to what? How many got C answer? Very good. It's the correct answer. After saying very good, 2 people raise the hands. Huh? Okay, 44 is the right answer. Why is not everyone getting the answer? Still doing? Try. Krishna, what happened to you? What is the formula here? PV is equals to nRT. Ideal gas equation. Number of mole is equals to given mass by molar mass. And when you mass by volume is there, you can use density in place of that. Should I solve or you want to try? I don't like this when you don't like response, okay? Solve? Okay, I will solve. Right, na? PV is equals to nRT. And instead of number of mole, you have to write mass by molar mass. See, you know this equation, PV is equals to nRT, ideal gas equation. Number of mole is equals to, guys, what are you doing here? Everyone, by molar mass into, let's say I move this volume there. Mass by volume is what? Density. So pressure is equals to dRT by molecular weight. Got it? Use this equation. Find the molar mass. Molecular weight by right. Vapor density has no unit because it is relative to the hydrogen. It is different. This is just density, not vapor density. 44 is the answer. Vapor density formula. Show me.
So we need molar weight multiplied by 22.4. So but 1.964 over out to 2000.
It will be 2. It will be 4 approximately. Why are you saying? And then
But nearly this was the answer.
so this is the molecular weight, no 4.
Huh.
So how is it near to 44?
So I took near 2000 so overall like 1.964 it is not sir. I took 2 sir.
I get it. Vapor density is equals to molecular weight upon 2.
22.4 sir. Molecular.
No, molecular weight upon 2, not 22.4. That is number of mole formula. You are talking about this formula, no?
Yes sir.
This is different formula. This is different formula. Don't mix it up, beta. Yes. Yes, I'm going to solve it anyways. Yeah. So everyone got the answer now? Yes. Which method you are using? No, you should get 44 around. Why? How 22.4? Okay, let's see. Okay, you want the molecular weight? So molecular weight will be, tell me, formula. dRT by pressure. What is density? What is R? What is temperature? What is pressure? Multiply it. $44 you are getting. By multiplied by? Because it is actually STP only. Because 273 Kelvin is what? 0 degree Celsius, right? And pressure is 1 atm. It is STP actually. But this is like just to ensure that we don't get any wrong answer. We can use this. Or either you can use number of mole is equals to V by 22.4. Then instead of volume, use. I guess I solved it like that, like before. That way also you can do. That is also right because this is nothing but STP only, right? Mass of single. Yeah, this is a good question. Quickly, the mass of single atom of carbon 12 in grams is. D. Who are saying D? That is the wrong answer. I know how D came. Because 1 AMU is equals to 1.16 minus 24, just like you do. No, that's the wrong answer. B is the right answer. So you can see how you can be tricked, okay? Solve it. Solve me and tell me how you have you done this question. Option? Krishna, solve it. I will see. What happened?
So 1.6
In grams.
Yes, sir.
So 12 you're getting answer. 12 grams.
So 12 into 1.6.
I'm saying no, I want the answer in grams.
The probability can say that it is.
Very good. The mass of a single atom of carbon 12 in grams is. You can start from the basic formula. Number of particle is equals to n into Na. Here it is asking number of single atom of carbon. So number of atom is equals to n into Na. N is what? Mass by molecular weight. And for carbon it is 12. Yes or no? Into Na. Just find the W given mass. That's why you just remember the value of 1 AMU into grams and just clicking it. No, it's not like that. 1 AMU is what? 12 gram when you have 12 gram. Okay, I'll solve it. Everyone please see on the board and please tell me what should I do. Number of carbon atom which will equal to n into Oh God. When I say please see on the board, solve with me. So you have to solve with me, okay? You have to tell me because I don't know anything. You are all my teachers when I'm solving. What is the formula of number of mole? Gram per molecular weight. So the question is saying the single atom of a carbon atom in 12 carbon 12 in grams. So grams they are asking. It means W they are asking. They haven't given, and we know that each atom of carbon is 12 AMU. Yes or no? And number of carbon atom is 1 because single atom they are saying. Any doubt till here? Please raise your hands. If you haven't understand the question, please raise your hands. I will tell you. Then this given mass you want to find. So 12 into 1 upon Na. It will be like this. So you will solve it. It will be around approximately 2 into 10 to the power minus 23, which is approximately 3. Got it? It was a good question, no? A lot of you got stuck. So even this small topic, this mole topic can trick you in exam. And I guess I am happy that I took the second class of this thing. A lot of you are still stuck in some questions. From now onwards, I don't want any one of you in such questions. Okay, if you see such questions in exam, you have to get the right answer. You cannot lose marks here. Okay, thank you.
We have so 1 mole of carbon atoms means equal to 12 grams if we take the mass. So 12 gram is equals to 1 mole atoms into 12 AMU. Because one
I don't know, understand. Just tell me again.
so like if we take 12 gram of carbon, we get 1 mole.
I get it. 1 mole.
And sir, if we take and sir, one atom has a mass of 12 AMU, so we can equate it.
I get it. What you're trying to say, I guess. You are saying, try to understand. What is the definition of 1 AMU?
1 AMU, 1/12.
1/12 of carbon 12. It means 1/12 of 12. Only then you will get 1 AMU.
Yes, sir.
Getting it?
Yes, sir.
It means when you will take 12 grams of carbon, only then you will getting 1 mole.
Yes, sir.
Your 12 gram of carbon has
One.
1 mole.
Yes, sir.
And his question, like let's say you are saying number of particles of anything, number of carbon atoms is equals to n into Na.
Yes, sir.
So in according to question, the question is asking explicitly of single one carbon.
Only
One carbon, and how much mass will it have?
how much mass would be?
Hmm.
Yes, sir.
So if it is not asking about the in grams, it's just asking about AMU. One atom of carbon will weigh how many in AMUs? 12 AMU, right?
Yes.
And then let's say you have to convert that into grams. What will you do? 12 into 1.6 into 10 power minus 24. You will get the same answer. Some of you guys, I told you to just convert AMU into grams. So there is a number 1.66 into 10 power minus 24. Remember? So he is asking like if we have like carbon 12, we know that it is 12 AMU. One single atom is 12 AMU. We can just multiply it by 1.66. Yes, you can multiply. You can get the same answer. When you multiply 12 into 1.66, you will get the same answer as it now. Yes or no?
Yeah.
So that is another method for solving this question. So in the next class, we will study about POAC. Okay. An empirical formula. I think when was our last class? 24, no? Okay. Let's since we have time, we can discuss about POSC, principle of atom conservation. So, what does principle of atom conservation tells you, beta? That the number of atoms before the reaction will be equal to the number of atoms after the reaction. So, reactant and products will have the same number of atoms. Simple. Okay. So, let's say this is example given here. KClO3 giving us KCl and O2. KClO3 giving us KCl and O2. Let's say I have n number of moles of KClO3 and I am balancing the number of oxygen atom, right? So whatever oxygen atom I have here, let's say I have 3 over here, I should have 3 over here also. Yes or no? So number of mole of KClO3 multiplied by 3 over here is equals to number of moles of oxygen multiplied by 2. Whatever number of atoms I have, is this reaction balanced or not? It's not balanced, no? No, 3 by 2, yeah, you have to do 3 by 2. It's fine. So we don't have to kind of worry about the stoichiometry over here. We just have to worry about the atoms. If the reaction is balanced, you have to just worry about the number of atoms. Okay. So in the question, let's say, if it is saying the moles of oxygen from 2 moles of KCl3, how many moles of oxygen I will get from, let's say, 2 moles of KClO3. So if I have 2 moles of KClO3 over here, 3 into 2 is equals to number of mole of oxygen multiplied by 2. This 2 and 2 will be cancelled. It means I will get 3 moles of oxygen atoms. We're not talking about molecules. Yes or no? So we have to balance the atom. For example, here calcium carbonate and calcium oxide. Whatever number of, let's say I have to balance carbon atoms over here. So number of mole of CaCO3, this is my reactant. How many carbon atoms I have in the reactant? 1. 1 into N into CaCO3 is equals to, now this does not have any carbon, will not consider this. This has carbon. How many carbon it has? 1. So 1 into number of mole of CO2. Similarly, this is for carbon. Let's say I have to balance oxygen now. So again, how many oxygen I have here? In one 3. So 3 into number of mole of calcium carbonate is equals to, in here I have oxygen in here also and here also. So what? I have to consider both the things, right? So what should I write? Tell me. 1 into number of mole of CO, very good, plus 2 into number of mole of, fine? Yes or no? Okay. Okay, let's write this in. H2O2 giving me H2O plus oxygen. It's not balanced. Now it's balanced. Okay. Now I have to balance oxygen atoms. So can you help me? So should I write? Tell me. 2 into number of mole of, very good, is equals to 1 into number of mole of H2, very good, plus we have, I told you number of atoms were balanced. Don't worry about the stoichiometry. Right now, just worry about the number of atoms. So it will be 2 into number of mole of O2. So just worry about the number of atoms in that compound. Okay, when you are balancing. I guess you will get the notes. Don't worry, we'll do some examples tomorrow also. You will get a better overview. Now I guess these questions you can like do it very easily. I'll just explain whatever we did. So this was the combustion reaction, right? We had to balance first carbon, right? How can I balance? Since I have X atoms, X into mole of hydrocarbon which will be equal to number of mole of CO2. In each CO2 I have only one carbon atom, that's why I multiplied 1. Fine. But for the hydrogen atoms, what will I have to? Here I have hydrogen in what? Y atoms of air, so Y into number of mole of hydrocarbon, which will be equal to, in this compound I have 2. Got it? 2 into number of H2 molecules. So see, this will be forming X moles, this will be forming Y moles or 2Y moles. I'm not considering the stoichiometric of these things, right? I'm just worried about the number of atoms. Fine. I'm just worried about the number of atoms. So don't have to worry about the stoichiometry here. Fine. That the stoichiometry part we will do. Like for 1 mole we need 5 moles, 3 moles, how many moles we need. We will do this question, don't worry. But for POSC part specifically, just worry about the number of atoms. If you are able to write such equations, you will do solve all the questions I'm telling you. So is it good? Now next one you will tell me. Again, I guess the same question, no? In this question was only difference was there were number of moles were not given. You had to find the number of moles, right? You want to do question? I have questions also. Sure. These are easy questions. Not specifically of POAC because POAC is being asked very less in the exams. I have to be honest. Like IIT and NAS, I searched the questions, but there were no like more question of this POAC. Generally asking JEE mains or advanced sometimes. Sometimes. Okay. So 7 minutes are left. Empirical formula again. You wanted to understand empirical formula, right? So let's say I told you 3 steps to find the empirical formula. First one was find the number of moles. Step 1 was what? Why I am feeling that I am teaching too much today and you are not in mood. You? No, I get it, but some of the students are new, no? I wanted to like for them. It's fine, we will study this topic tomorrow because it's already too much for first day for some students who are coming for the first time. And whatever questions you did today, like whatever being like moles or your POSC, please try to go and solve your module from there. Okay, and you can ask me questions after the class. Fine. So we are ending the class today. This one I don't think we have to save. We already done this thing. It's fine, they will do it. Yes, any doubt? You can come. Yes, you can come to us. Hey, where is that guy who wanted to ask questions? Come.
I think these are viewers me again tomorrow, okay? Someone has doubt, and I will bring so many questions in the class. Then, no question. You guys will study tomorrow in detail, okay? And I will bring a lot of. Bye-bye. See, I think here is wrong. 7:31. Next one is at 45.